This video introduces a new method for charging electric cars. Tire deformation is the key to this system. Automotive tires deform with the weight of the vehicle. As you can see here, when the tire comes in contact with the ground, the bottom of the tire deforms to take the shape of the road. This deformation can be used to push air through a piston. A piston can be attached to the rim of the wheel with the piston rod affixed to the tire. As the wheel rotates counterclockwise, the tire deforms and pushes the piston rod upwards. The piston compresses and sends air through a line. A rotary union can be pressed into the center of the wheel, with the opposite end of the rotary union attached to the body of the vehicle. The air line can connect to the front of the rotary union and transfer the compressed air to the opposite end of the union. Now, another line can connect to the back end of the rotary union. The compressed air can travel through the line and blow a fan that is attached to an alternator for charging battery. If we strategically place several pistons, air can be compressed and routed towards the alternator at more intervals with respect to the motion of the wheel. Here is the air schematic of the system. The 3 check valves at the bottom allows air to flow in only one direction, while the 3 check valves on the top allows air from the environment into the pistons during piston retraction, preventing suction in the system. As a recap, the overall system schematic is shown here. Ground reaction force of a vehicle is used to compress air inside a piston, route the air through a rotary union, and used to activate an alternator turbine for charging a battery throughout the motion of the vehicle. Energy can be harvested from the road during the motion of the vehicle. Energy can be stored with very high efficiency during downhill motion of the vehicle. This system can be used to drastically increase the range of electric vehicles. Instead of using air, hydraulics can be used with minor changes to the system to amplify the energy if needed. This system will also have an impact on the robotics industry. This example shows a simple overview of implementing hydraulics into the system. A master cylinder can be used to conserve the fluid within the system. A multi-channel rotary union can be used to transfer fluid to the front of the wheel. Instead of blowing air, a secondary piston can push a rod with amplified force. A translational to rotational mechanism can spin an alternator for battery charging. Next, I will show you a video of a prototype that proves the concept. This video will show that air can be pushed through the hydropneumatic energy wheel efficiently. First, let me go over the prototype. An electric motor is mounted in the box on the left. A pulley is attached to the shaft of the motor that will drive a belt. The box in the middle is where the wheel is attached. On top of the wheel, the pistons are mounted. The tank on the right is designed to cool the system and prevent the pistons from overheating. The piston rods are designed to hit against a metal bracket that is attached to the wall and compress as the wheel spins. All the air lines running from the pistons connect to the rotary union at the center of the wheel. An air line connects to the bottom of the rotary union and runs inside the water tank so that bubbles will be visible once the system is active. A motor placed inside the tank pushes water through a line that runs through the bracket on the wall to cool the metal that heats up due to impact from the piston rods. A power supply activates the electric motor. It's time for the video. Thank you for watching.